Hey all, welcome to another session with me, Varun at OdinSchool. And in this session, let us understand what machine learning is and how do we work on machine learning with Python. And this video or this course in specific, it would be a bit theoretical for the first 1.5 hours, and then we would directly move on into the hands-on part, wherein we would be looking at the other concepts or other topics of machine learning like linear regression, logistic regression, decision trees, random forest, and we'll just keep going forward. Now, to give you an understanding about why do we have to learn machine learning and what is machine learning, first things first, let us understand what machine learning is in the first place. Well, talking about machine learning, I would say that it is a technology rather. Well, there's a good number of people who call machine learning as a language, but guys, machine learning is not a language. It is not a language. Rather, I would say machine learning is a concept or it's an idea or it's a set of technologies. But I wouldn't call machine learning a language, okay? Or you can call machine learning as an application. You can call it anything except a language, okay? Now, just to understand what machine learning is and why do we have to learn machine learning, guys? Machine learning is a part of artificial intelligence. Now, everyone who believes that you should be learning data science or you should be having a firm grip on understanding what machine learning is, then it should I mean machine learning is a technology or is a concept which provides or it should provide the system with the ability for itself to learn automatically without being or without having the necessity to code explicitly each and every time, right? So in short, machine learning focuses on evolution or now evolution of learning, wherein it is just a simple piece of code at the beginning, but as the code keeps going into the real time set of events, it is learning. And it is learning wherein it's trying to imitate or wherein it's trying to come up with the best possible output as compared to the past. So this is how we can define machine learning as, and I hope now you all have understood as to why machine learning becomes very important for us when we throw ourselves open into the field of data science. Now, going forward, the next thing I would want to talk to you about is introduction of the Odin School, guys. We at Odin School, we are a technology upskilling platform, and we strive to continuously help you acquire new skills. Thereby, you could stay skilled and stay ahead. And my name is Varun, and I have an overall experience of somewhere around 7. And over this tenure, I've been working as a developer and as a trainer, and thanks to the different organizations I've been working with, I have been able to gain knowledge on HTML, CSS, JavaScript, R, Python, machine learning, deep learning, etc. Wherein some of them are languages and some of them are a mix of concepts and technologies. So yeah, this is a bit about me. And the agenda, I hope, must now have been understood. The agenda is to understand what machine learning is, to introduce you into the concepts of machine learning, to look out what are the different topics that we would be dealing with in machine learning. Thereby, we will be moving on to what are the different areas of implementation for machine learning. We would be looking at what are the wide range of areas followed by some real-time case studies, and then we would be understanding the two kinds of machine learning, that is supervised learning and unsupervised learning, and how are they different from each other, and some examples to follow after them as well. So without delaying, without wasting time, let us quickly move on into the topic. Right, so this here that you're looking at is the definition of machine learning. All right, and what is it? Let us just understand this. Machine learning is basically concerned with the programming of computers, which automatically improves the performance through experience. Now, this is exactly what we spoke just a while back. Now, when we talk about machine learning, it learns each and every time. It does not kind of stop with one single input and output. The process keeps going. Now, the primary aim is to allow systems to learn, and the secondary aim is to ensure that this learning is an evolution. Right? Now, how do we, kind of understand this? Here, we have, different kinds of algorithms which we use, okay? Now, machine learning mostly uses the keywords and how or what is the flow that you're trying to bring about. Now, it could be starting from analysis of a known training data set or the learning algorithm which produces a function to make predictions or anything. Here, the learning algorithm can compare its output with the correct intended input. Now, in this process, you would be having errors. All right. Now, this is one variant wherein the error is to be reduced each and every time. That is supervised machine learning. Likewise, there is unsupervised machine learning as well, wherein the system does not know what the right output or what the right answer is, but it explores the data and it can draw inferences from data sets to describe structures or hidden structures from unlabeled data. Thirdly, there is also something called a semi-supervised machine learning algorithm. Okay, let me just make a note of that, like what are the different kinds of algorithms. So the first one we all know is supervised. The second one is unsupervised. The third one is semi-supervised. We got this too, not to forget. Then we have reinforced learning or reinforced as well, right? Now, when we talk about each of these, let us just understand the difference. We now know what is supervised, wherein the input knows what the output is, and based yeah, I mean the input knows what the output would be, and here there would be the process of error betterment, which would keep happening over every process. When we talk about unsupervised at the other place, this is moreover used to find out or to describe hidden structures from unlabeled data. That is the uh, definition or understanding for unsupervised, though we would be looking at them in detail as we keep going forward, not to worry about it. Then the third one is semi-supervised. Now guys, what is semi-supervised? They are a mix of supervised and unsupervised. Here typically a very small amount of labeled data and a large amount of unlabeled data exists. And the systems that use this method are able to considerably improve the learning accuracy. Okay, so here each and every time the learning accuracy is improved. And also, we would not require a lot of data to be coming in each and every time. This semi-supervised learning works moreover on the principles of unsupervised only. And then finally, we have reinforced learning. And in reinforced learning, you have a lot of other new techniques or new methods. For example, you have trial and error search, just to make things a bit easy to understand. Let me just mark things here. We have trial and error search, right guys? Then also notwithstanding this, we have different delayed rewards that can be uh, accessed. Uh, the next thing here is this method, it allows the machine and the code in it to automatically determine which of them is the most ideal behavior for the machine. Like there is something called as a simple reward feedback system. Let me just write it. Simple reward feedback system. And based on these, feedbacks which we give or which we render, right, we would know or we would notice that we have a to and fro process that keeps happening. Now, when we talk about machine learning in general, it enables analysis of massive quantities of data while keeping in mind that it generally delivers faster or more accurate results in order to identify profitable and also some good decision making opportunities, which could also be considered as risks. And when we are working on things which keep getting complex, it's not that your machine learning has become slow. It is just that the complex process would require additional time and resources to train your machine properly. Right, guys? So I hope it is now understood that machine learning is a small but yet a very important part of artificial intelligence. Point one, we have understood what machine learning is standalone. Point two, we now know what is the difference between supervised, unsupervised, semi-supervised, and reinforced learning. That is point three. And now going ahead, let us just talk about some real-time projects that we have which are available in the market based on machine learning only. Again, just to keep things clear. Now, here when we talk about machine learning, we all know that data is one of the most important for all the business heads or for any business to happen. Like if there is no data, I would say that business is as good as how it was. Now, data need not necessarily mean that each and every time there is only 10 TB of data. But guys, whatever is the data that you have, that data should be preserved, or that data should be understood every day. That data should be worked upon. That data should be crunched to find out what has happened or what can happen. Now when we talk about machine learning, it is all about crunching this data, or it's all about uh, pulping this data out, wherein you know that once this data is pulped out, the only thing that is left is for you to analyze. Now, with such a huge volume of data, it becomes very important for us, or rather imperative for us, to use things the right way. Now, you would not use 1.3 terabytes of data to work on a machine learning linear regression algorithm. That would be totally foolish, and that would be like one of the biggest blunders that any person can do. But then what would you do with that kind of a data, or how would you gain the necessary information for you, or doing what would you be able to use that 1.3 TB of data which we were just talking about? And guys, 1.3 TB or 10 TB is nothing, because one laptop has that capacity nowadays. So if we are talking about an organization, then I would just want you to imagine the breadth and depth of the data they would be having. Anyways, coming back to the topic, when we're talking about machine learning can be the key to unlock the value of corporate data and get decisions. See? Now, when we talk about decisions, what kind of decisions are they? Guys, not every decision that we see or that your system is trying to show you I mean, not every decision is over the table, and not every decision is a path breaking way. There are softer or milder decisions, and there is path changing decision. Now, if in case I would want to know how many customer, and there are softer decisions. Now, when I talk about this fact that there are 50 customers entering my shop, a print with the name X2. Now, guys, if you were a shopkeeper, what would you do? Right? What I would do is, now that I know that there are 40 people who are buying only X2, I would identify another product which is less sold. For example, a pair of socks. Now, when I have these socks or when I have things like these, I would not use them. Now, when I have information or when I have to make software, I mean the difference between software decisions and path changing decisions. So let us assume that out of 50, 40 people are buying a t-shirt, and there are there is one product which is socks, which is being very less bought. Okay. Now, what I would do is, as a store manager, I would try to ensure that even these socks are being sold out. So what I would do is, I would come up with an offer, that is, buy one shirt and get one pair of socks free. And in order to keep the price balance at par, I would probably very marginally or negligibly increase the price of this t-shirt, and I would see how that would affect my customers. And if that's fine, that's lovely, nothing like it. And if it is not fine, I would revert back the changes. Now, this is just one example. Let us assume that you are working for a BPO or a call center, right? A BPO or a call center, and I have asked you to give me, or probably you have given me a list of calls that you have. Okay, now this is the list of calls that you have. Out of this, I would now try to identify, or probably there is some other senior manager over me who is asking me what are the major areas of problems out of three sectors, like signal, or probably internet, or probably the billing plan. Right now, I would ask my team. Okay, so this was asked to me, and I am the manager. Okay, now how would I give my senior manager this information if I don't have any data? So what I would do is, I would talk to or I would collect information from 4 to 5 callers, and I would ask them to give me the whole list. So I would be having a list of, now if this has a list of 40 people, I would be having a list of more than 400 people now. Now, based on this list, I would see what are most of the calls coming from. I infer that 150 calls are for network, 200 calls are for cost, while only 150 calls, or okay, let's make this to 180, or probably only 120 calls are for signal. Now, based on this, I see that 200 people are calling me for cost. So, I would now communicate this back to my senior manager. He would now make the requisite changes on this bill, and the decision would then be floated across to the organization, and then it would also be brought onto the fore. So guys, this is the way how we work on machine learning, and this is what we do when we have information to be exchanged, or this is how we work when we have decisions to be made in an organization. It is not the way we look at it. It's not like there are 4 to 5 people sitting, they bring files and then they discuss and then the decision is rolled out. Guys, that's not how it works. All right. Now, I would want to take this a bit further now that we have understood where it is used and one small case study. Right. So, here you can see are a list of some very, very important sectors where machine learning can be used. Right. Of these, let me just talk about a few. Let me just use a pen as well. Change the color. All right. All right, so the first one that we have is, now this is a topic that's being entertained because a lot of people who are choosing machine learning or deep learning or probably the set that is data science have a very big confusion as to what is the role that we would be eligible for. A. B. There is also another well spread notion in the market that if I am an engineer, then I would fit only into the roles of probably an IT company, and I might not be able to work for a bank or a healthcare sector. But guys, that is utter that is utterly wrong, to be very honest, because even if you're working for the energy sector or financial services or travel and hospitality or manufacturing or retail or health and life, these are just a few. These are just a few because here I still don't see e-commerce. There are a lot of other sectors that are missing. Okay, that's just one example. Right. So now when we talk about data science and machine learning algorithms or data science to be specific, guys, you might fit in into any industry. This field is not industry specific because for all I would want you to do is use Python or R as a language and come up with machine learning concepts. I don't want you to come and design a whole database for me. So it really does not matter even if you are a BTech or even if you come from any different background, right? So guys, please keep in mind and please note that whenever you are working on data science, the more important thing or the most important concept here is to understand if you fit in to learning the technology or not. Services, for example, when we talk about energy feedback, you see you have seismic data processing, you have power usage analysis, energy demand and supply optimization. The same is for financial services. Financial services are moreover into banks related, right? So here you have credit card worthiness evaluation, your customer segmentation, etc. Then you have travel and hospitality, wherein you have dynamic pricing, aircraft scheduling. Okay, so guys, there was a small technical glitch, I suppose. Well, so these applications which you're seeing on the left hand, that is the famous set of applications that we have been using over the past 1 or 2 years. We have seen how Amazon has developed step by step. Right now, let us just talk about Amazon as an example to justify the stand of machine learning. So, when we initially downloaded Amazon, probably somewhere at around 2000, somewhere between 2014 to 2018, we would have noticed that Amazon has had very less features on its application too. Like you could only order a product or cancel a product. There was nothing else. And you could just scroll through some products that Amazon had. But nowadays, there are so many new features like Amazon suggests you what to take. Amazon recommends us on what to take. There is a difference between suggestion and recommendation, guys, though the difference is very hairline. Then it would also be showing you some offers that you could avail. It would be giving you an idea of the entire history, like right from when you ordered till it is delivered. We can, put this as, let me rename this as order to delivery history you have. You would be having the GPS. Well, I don't think we should call it the GPS. You would be having the tracking detail, is what I would say. Yeah, you would be having the tracking detail of where your shipment is and many other features. We have a chat bot that is embedded into the Amazon app. So guys, these are just some features that I could think of right now. Notwithstanding these, there are so many other features which Amazon has come up. Forgetting Amazon for a while, let us now move on to the next mega application, which is Instagram. Uh, Everyone, please let me know if any of you have no idea about any of these applications. I'm sure you all know. Now, talking about Insta. Insta has come up with some real great advertising features. Now, this is not something that's known to all the users, but this is something that would be known to people who are trying to advertise or who are trying to make a sale, or for people who are artists, or for people who have some product to be sold, or people who are into business. They could leverage the use of Instagram advertisement. Instagram has also come up with something called as Reels. We all know what Reels is. In Instagram, there is also photo tagging. Now, you might say photo tagging is everywhere, but guys, you have auto photo tagging. Now, what is auto? Just in case I upload a photo, it would tell me that this photo belong. Now, if there's a group photo with 5 people in it, we are all friends and we're all just sitting randomly. This is me. And if I have another 4 people, Instagram would give me suggestions that this is X, this is Y, this is Z, and this is A. I wouldn't say they're always 100% correct, but yes, they match by 80%. The same thing is with Facebook too. So this is another feature. You could add filters, you could change stuff, you could see stuff, you could add places, you could add GPS locations, you can tag people, you can take reactions, you can come up with hashtags. Everything that you see here, guys, is an algorithm. And this algorithm which we're talking about is very, very important for us if we want to work on machine learning, and if we're looking forward to make our systems intelligent, right? So this is or these are the places where machine learning is or was playing a significant role. We all know some more applications now. These applications which we're talking about has more to do with images. Uh, Now let us talk about applications which have more to do with textual content, or which have more to do with sound and stuff like these. So here I have Shazam. What does Shazam do? Guys, let us assume that you're playing a song on your TV. Or earlier, this used to happen very rampant, wherein we had friends, they used to ensure that they had some very good songs with them. And when they would come and play things for us, we just had to listen to them, and you had to request them to know the name of the song. But since the invention of Shazam, things have changed a bit. You don't have to ask any person for what the song is. You can just keep your Shazam open. Let Shazam listen to it, and it will come out with what song it is. How cool is it, isn't it? So guys, this is called audio recognition. So we have applications like these which have really acted as breakwaters. They've changed things once and for all, right? Now, when we talk about supervised learning, sorry, when we talk about machine learning, so both of these, that is supervised and unsupervised, they all fall into machine learning only. I hope we are in agreement with that. Now, let us also understand the difference between each of them, and why we might need them. Now, first things first, when we talk about the supervised model, right, we would be having a classification and a regression branch, right? Now we would be starting with regression from the sessions. Oops. We would be starting with regression from the session to come. We have something called as linear regression. That would be the first topic that we would be beginning with, right? And when we talk about different regression models, or understanding what regression is, Well, regression is a process of finding out the relationship between two variables. So here this is x and this is y. So I can say that 10, 20, 30, 40, the same here 10, 20, 30. So I can say that with unit rise in x, there is a substantial rise in y also. Now, if the same graph were like this, horizontal, like parallel to x-axis, right, guys? In this case, I wouldn't call this linear. This is not linear. Why? Because there's no relationship between x and y. So the first algorithm that we would be focusing on from the next session would be to understand what regression is. As simple as that. And when we talk about regression, regression becomes very important process, or one of the most important processes in finding out the relationship between two variables. And there are a lot of types of regression that we have available. We have linear regression, we have multiple linear regression, we have polynomial linear regression. So yeah, there are many variants of regression, nothing to worry about, right? Then the second one which we have is a classification model. As you are able to see, that is the first one that we have on boards. And a classification model is more about a binary decision. It's like more of a yes or a no kind. When we talk about a classification, here you would be making a choice based on the information that's provided to you. We would have to come up with, would it rain or not? Is he healthy or not? Is it cancer or not? So for things like these, we would be using classification. Now, when we talk about classification, we all know that in classification, there are a lot of variants. To begin with, we have things from linear regression. Sorry, guys, it's not linear. Please pardon me. When we talk about classification, we have things from logistic regression to decision trees, to random forest, to KNN, to SVM, to naive Bayes, to even concepts of neural network. Guys, in all of these places, the only thing that we would be using is a classification method. And all these algorithms work on classification only. Though there are different types of classification which is associated with different kinds of data sets. That is something to be kept in mind, and that is something that we would see as we keep going ahead. But guys, regression and classification become outrightly important for us when we talk about machine learning algorithms. Now, we know how supervised and unsupervised are different from each other. When we talk about supervised, here in supervised, you know, or you can gauge your input and output. But in unsupervised, you only know the input. The output is something to be waited for, because the output here is a huge conclusion or a derivation that comes up. It's not just a one-step process as we think of. Then in line or in order, the second one that we have here is about unsupervised learning. Now, giving a sharp turn towards unsupervised. Guys, if supervised works more on the lines of prediction, oops, it's already written here. If supervised works more on the lines of prediction and coming up with predictive models, unsupervised comes up with pattern. Unsupervised, the job of unsupervised is not to predict. And then again, guys, when we use the word prediction, there is a good number of people who get confused for prediction as future. Like predict is a future tense, like I will become a cricketer or I will become an actor. This is future prediction. But guys, that's not what we're doing here. That becomes more of astrology. right? We are not doing that here, guys. That is not what we are doing. We are not predicting for future. Why? Because like whenever you're talking about future, or whenever you're talking about anything from the past or anything about the future, then guys, here you have to know that you also have time which is taken into consideration. And if your data set is independent of time, like it has no variable time, then you cannot associate it, or you cannot connect that algorithm to future or past, because that's not how it is meant to be. That is just an improper understanding of your algorithm, or of your data set, or of your problem statement. Right, guys? So now let's go forward. Now that we have understood very clearly what is supervised, what is unsupervised, and some examples within it, we shall now move on to understanding unsupervised learning and things in and around it. Now, when we talk about unsupervised, guys, here things work a bit different. I mean, even in terms of coding paradigm, we would not have to work on creating a training set and a testing set, and all this process becomes immaterial as far as unsupervised learning is concerned. And why is that? Guys, because when we work on unsupervised, as you can see on the top, we have nothing to do with the output. Or output is rather not in our control, or output is something that gets evolved based on different calculations that we provide. Now, this is where supervised and unsupervised differ, right? I also agree that unsupervised is one step ahead of supervised, but if it is, it is. Right? Now, there are different concepts, or there are different topics that we have associated in unsupervised as well, of which first and the foremost is clustering. So, when we say clustering, clustering is K means. KNN, guys, is onto the supervised side, while K means is onto the unsupervised side. Right? Now, when we talk about K-means, here, K-means mostly tries to find out clusters of data. Like I have triangles, I have circles, and then I have some lines. So it would give me three clusters: cluster 1, cluster 2, and a cluster 3. Right? K-means is used in some real time scenarios, like you could consider image compression, wherein a photo with 16 million colors can be reduced to 16 colors. Now, this is exactly what happens when we shoot a photo on a professional DSLR, and then when it's imported or exported into WhatsApp, we see that a photo of 20 MB also is reduced to 500 KB, or to a very minimal size. Now, guys, how does this happen? This happens because of a process known or called as clustering. Clustering is K-means. K-means is unsupervised. KNN is supervised. KNN is classification. K-means is clustering. So would want you to remember these differences, because they're very important for us to bridge the gap. Right, then in order, the next one we have is association. Now, what association are we talking about? When we talk about association, it means working on market basket analysis. That is MBA. Right? Now, what do we mean by market basket analysis? Now, this is used when your input is a list of transactions. right, guys? Now, what transactions is it? It is the transaction of 1 month of uh, shopping list, probably, or I have a bill of 1 month, and this bill gives me a list of all the transactions. Hope it's very simple. Now, this bill which I have would not give me the date and the username and his address and the gender and all. It would only give me a list of transactions and the number, like one, so many items, two, so many items, three, so many items, four, five, and likewise. So, guys, this transaction is taken into market basket analysis, and here we use something called as A rules. A rules can be understood as association rules or a priori rules, interchangeably called, doesn't matter. But these are some rules which we use in association to find out how many items have been sold, or to find out the frequency, or to come up with some new offers, or and things like that. Then finally there is also another, guys, which is called as time series analysis. This is also unsupervised only, but let me stress here, but when we talk about time series analysis, this process involves a lot of steps. Like, to begin with, you have in time series analysis the intake of data with respect to time. Like, you have one column, or sorry, you have one of these which is dedicated to time, right? The other is one independent variable. That's it. And in time series analysis, we would be calculating different things like trend, or probably how it would be after 5 years, that is the future, or things associated with time, right? We would be calculating the seasonal behavior of a product, or how it would behave after 10 years. Like, this is a future graph, right? So we have things like these which are very highly, or which are very famously used in supervised and unsupervised models. So, guys, please understand that in machine learning we have two variants, supervised and unsupervised, both of them doing two different jobs. And within supervised we have two more branches, like classification and regression, wherein regression is to find out the relationship between A and B, while classification is to come up with the difference between A and B. And then when we talk about clustering, clustering is to identify patterns, while association is to come up with uh, better suggestions, or better product based recommendations. Now, these product-based recommendations are to ensure that there's a smooth sale, or better sale, or pickup of a product, or probably failure of a product. Or if one product is least being sold, you might want to push it into the market. And how would you do that? You would do that using market basket analysis. Because if I have two products which are not in demand, I would definitely not combine those two products with an offer, because in that case customers would be least buying it. So the best logic, or the most approachable logic here is, I associate my least selling product with the best selling product, so that at least the least selling product would start to move, right, guys? So this is how we bring about things, or this is how we bring about change in the market field. Everything that you see that we talk about is in demand or is not in demand is not something that we decide. It is something that market decides with time, and all this can be calculated. We don't have to talk like laymen. saying that things have been in demand then and they're not in demand now. We can also analyze as to what is the ratio of demand. How in demand were they then, and is the demand really reduced or is it just a cast upon effect? Things like these are very important when you are a manager. They may not be very important to us right now because we don't own a store, we are not answerable to the sale of any product. But when you are answerable, you would definitely want to look into insights like these. And that is where machine learning is trying to make lives easy of many people, many stores, and many developers by coming out with information that is more crisp and much more easier to understand. Right, guys? So I hope that in this session you have understood what is the broad difference between supervised and unsupervised learning, how we learn them, and why do we learn them, right? And just to give you all another small look at different kinds of streams that we have within every field or every branch. For example, within marketing, there are so many applications that we work on. And then we have healthcare. Within healthcare, as you can see, there is predicting health, there is risk assessment of patient's health, there is diagnostics. Again, they are different types of, you have default reduction. Now, this is insure tech. Okay, guys, this is how, okay, these are the different sectors. So, this is premium rate optimization, all these here. These are different fraud detection techniques. These are defaulters reduction, claim automation, and predictive analysis. So, guys, there are a lot of sectors and a lot of fields or branches where you could fit in. And if you are really looking forward to learn data science or machine learning, your last concern should be about searching for the industry, because trust me on this, the day you learn data science and you're able to understand information and you're able to come up with analysis on your own, you don't need an industry. The industry needs you because they are the ones who are looking forward to gain information from the data and not us. So, guys, stay rest assured. Ensure that your concepts are right, ensure that your understanding is sound, and I'm pretty sure that the journey would be very smooth and very easy to flow. Thanks a lot for your patience. I hope each and every one has understood something out of this session and you have gained some information which you could probably use in your way to go, right? So I hope you all have now a good command over an understanding of what machine learning is, and you can also define this to people or train people now. You can talk about what are the different areas of implementation and supervised versus unsupervised learning. As said, thank you very much for your patience. I understand that this session, being inclined towards theory, must be a bit slow and must be a bit dry. But guys, I would make it up to you in the sessions to come, because as we keep going further, we only have hands-on and less of theory to get exactly vice versa. We would be having no theory left to talk as we keep going ahead, because there would be a lot of hands-on. So stay tuned, stay subscribed, because there's a lot yet coming up on our channel on a daily basis, or rather on an hourly basis, and you would not want to miss any of that. Thanks again for your prolonged interest. This is me, Varun, your trainer, your mentor, signing off, wishing you all the best for whatever is the field you're about to choose. Have a great day ahead.